You're watching The New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show. Okay, I'm here with Janikiram MSV, and Johnny and I have had a few takes here, but I think we got it now, Johnny.
Perfect.
Great. So Johnny and I are going to talk about LLM observability. I'm going to be asking Johnny a series of questions based on an outline that he provided me before our talk. These are going to be slides, and they'll also be presented with this presentation, and you can view this on the YouTube page for the New Stack if you're listening to the audio feed. So what we're going to do is look at a few core topics. We're going to look at what is LLM observability. We're going to look at three questions there. What is it? What is LLM observability versus infrastructure observability? And then we're going to look at LLM observability versus machine learning observability. And then we're going to look at some key areas, and I'll talk about that when we get there. And then we'll get into the ecosystem. Who are the companies out there? So Johnny, let's start right away. What is LLM observability?
Yes. So in the last 12 months or so, there is a new stack that has evolved, and that is the LLM stack, which has multiple pieces of the puzzle, like the large language model, the vector databases, the embedding model, the retrieval systems, the re-ranker models, and it's a whole new ecosystem. So making sure that we are monitoring the golden signals that come out of this new stack and making sure that we are getting what we want out of the system is primarily the objective of LLM observability.
Okay, so that is LLM observability. So now we're going to take it to the next step then. What is LLM observability versus infrastructure observability?
Right. So folks who are familiar with DevOps and SRE based metrics, they already know what is infrastructure observability, right? The goal of any observability mechanism is to make sure we have insights into a system. So in infrastructure observability, we look at four golden signals, which are called as MELT: metrics, events, logs, and traces.
Mm-hmm.
Now, if I am a systems administrator or an ops guy, I am responsible to measure these four metrics and keep an eye on them to ensure my systems are delivering the uptime, which is 99.99% or whatever is the SLA.
Mm-hmm.
Now, very similar to this, LLMs also have certain metrics, but they are entirely different from what we have been tracking for infrastructure, which we will do a deep dive on.
Okay. All right. So now the last bullet point you have is LLM observability versus ML observability, meaning machine learning.
Right. So there is another misconception that whatever worked for traditional machine learning models would continue to work with LLMs, and that's not the case. As I mentioned earlier, the goal of observability is to give us insights into a running system and ensuring we are getting the expected outcome. It could be uptime, it could be accuracy, it could be any of the defined metrics. Now, in traditional ML models, the goal is prediction, predictive analytics. And what can go wrong with that and what needs to be measured there is basically the drift between the actual ground truth and the data that is being sent. Now, when the model is running in production over a period of time, it might actually deteriorate in its ability to predict because of this factor called drift. So a lot of MLOps observability systems primarily measure the drift of the models. While in LLMs, drift is taken. It is assumed because I'm very sure you would have seen ChatGPT saying, "Hey, I'm cut off on September 2022 or whatever is the timeline, and I cannot answer because I'm not trained on the data after that." So we assume there is drift with LLMs, whereas in traditional machine learning models, where the goal is predictive analytics, we cannot accept drift. So those are the fundamental differences. And we haven't still talked about the metrics of LLM observability, and that is the theme of the next segment.
Okay, great. So we're going to get into the key areas of LLM observability. And you break it down by the Gen AI stack, and that has several subtopics, including the GPU, the CPU, the storage and vector database, the model serving, the model usage, the chains and agents, and the application. And then there's several other topics such as hallucinations, span traces, relevancy, retrieval models, latency, usage monitoring, and user feedback. So let's start with the Gen AI stack and break it down by GPU, CPU first.
Right, absolutely. So today, if you consider how enterprises are consuming Gen AI, there are two broad mechanisms. One is running the models in-house, within the data center on-prem, or they consume the model exposed by a cloud provider or a foundation model provider, like Cohere or Anthropic or one of those, AI 21 Labs or one of those. So let's first look at what are the metrics that we need to monitor when we run LLMs on-prem in-house. And for that, we need to understand how this stack is going to look like. So the bottommost layer of this stack contains accelerated compute, which is very high-end CPUs and GPUs. Now, monitoring the usage, whether these resources, the infrastructure resources are oversubscribed or undersubscribed, is a key metric. And we already have enough mechanisms to track that. So that is the first layer. The second layer is the storage layer, which is going to be your model catalog or the model garden. Now, this needs to be in sync with an external model provider like Hugging Face, because that's where you're going to pull the models from. So if there is a new revision, if there is a better version of the model, you need to make sure there is the gap is always minimal. You're not running an outdated or an obsolete model. So that is a metric to track when it comes to the storage and the model catalog. And then there is vector database. Vector database contains the embeddings and the vectors of your ground truth, and keeping that up available and keeping that always highly available is very critical. So you need to treat that like the way you treat your Postgres or MySQL or any other database and ensure uptime of the vector database. And then the third layer, above this, is basically where you have the inference engine. So the inference engine is a combination of two things. One is it's a model serving environment. It basically picks up the model that is stored in the storage, and it applies the adapters, the quantization, weights, and it assembles all of that and then exposes that through an API endpoint. So it's an API server plus a model serving tool. So you need to monitor this to make sure that the endpoint is always available. You'll perform some health checks. You'll monitor. Think of it like any other API endpoint, but it needs to be monitored very closely because that is the most critical part of this entire stack. Now, on top of the inference engine, you have what is called as the tools or the agents. Now, these are, for example, LangChain, Llama Index, or any other orchestration tool that you are using, which is basically orchestrating the LLM invocations, by making sufficient making calls to the LLMs and making sure that the prompt engineering is in place. And they basically go back and forth, taking advantage of the LLM's reasoning capability, and they are acting like agents. You send one prompt to the agent, it will break it down into 10 prompts, and it goes back to the LLM for each of those prompts, gets the response, stitches all these responses back, and then gives you one answer. So this layer is very critical because that is what is orchestrating various calls between your embedding models, your vector databases, your LLMs, and all of that. So that is the chains or the agents that you are actually running. And then the topmost layer is your application. Now, this application could be a chatbot or it could be an AI-infused application. And it is a typical web app or a mobile app or a desktop app or anything which is consuming the agent and the tool that you are exposing through this stack. So when you are running this on-prem, this is how you visualize the entire stack. And you got to basically have observability in place to make sure this entire stack is available and it is up at all times. So that is the fundamental mechanism to monitor your on-prem Gen AI stack.
Mm-hmm. Now, hallucinations comes up.
Yes. Now, I just talked about the entire stack of the Gen AI environment if you're running it on-prem. Now, there are metrics that I called out, like the uptime and metrics logs, the traditional infrastructure observability responsible for your entire stack. But you don't have to worry about any of that if you are making an outbound call to Amazon Bedrock or Azure OpenAI or OpenAI's API server. But in that case, what are the metrics that you need to take care of? What is that you need to really monitor in case you're not owning the infrastructure? So there are a set of metrics that you need to start monitoring, and they form the core LLM observability stack. Now, these are common to both GenAI stack running on-prem and even the GenAI stack that is hosted by someone else, right? So these are very, very fundamental to any GenAI application, irrespective of where the model is hosted. So these are the baseline metrics that you need to track, irrespective of how you consume the model. So the number one metric is hallucination. So hallucination translates to what is called model evaluation. So, and the way it works is you have a slightly less capable but a cheaper model that doesn't require a full-blown A100. It can run on a smaller GPU. So you send a prompt, the LLM comes back with a response. Now, how do you know whether this is accurate or not, or whether the model is hallucinating or not? So you take the same question and the response and send it to a more powerful model like GPT-4 or Claude 3 and say, hey, I sent this prompt to this model and I'm getting this. Is this helpful? Is this harmful? Is this reasonable? And now the most powerful model comes back and says, well, this meets this criteria. It is not hallucinating, it is helpful, it is not harmful, and it is reasonable. And that's a mechanism, that's an affirmation that the model is not hallucinating. Now, this is also applicable when you are implementing retrieval augmented generation and sending context to the model along with the prompt. You can pretty much do the same thing by sending the prompt plus context to a more capable model and validating the response by saying, hey, is this correct? But now if you look at it, you're actually spending twice, one on a smaller model and one on a larger model. But you got to do this when you are particularly rolling out a fine-tuned model or implementing RAG for the first time to make sure your model is not hallucinating. So how often is this hallucination is showing up and how often the more capable model is raising a flag is a metric that you got to track. That is what is model evaluation or reducing hallucination. That is the top metric.
So span traces ranks as well.
Yeah. So span traces is very, very relevant, particularly if you are using something like LangChain tools or agents. So what happens is when you ask a highly complex prompt or a question to an LLM, the LLM will basically go back to the agent will go back to the LLM multiple times, verifying the response, right? So, for example, if you say, who was the president of America when Michael Jackson did his first public live concert?
Right.
Now, this prompt is pretty complex, right? Now, the agent will break this down. It will first break it down to finding out the date and the year when Michael Jackson performed his first live concert. Now, it will go back and ask the LLM, hey, do you know when this happened? And then the LLM comes back with a date saying this is when this actually took place. Now, the agent has the date. Now it says, take this date and then go back to the LLM to say, hey, who was the president for United States for this specific timeline? And then the LLM comes back with a response. Now the agent stitches these two things together and comes back to you to tell you that, hey, the American president when Michael Jackson delivered his first concert was so and so. Now, if you look at this, a single prompt is broken down into multiple steps, and for each step, the agent will either invoke the LLM or an external tool. And this is almost like a call trace in traditional application performance management tool, right? It's like APM. You have cascading functions calling one after the other, and you want to understand what is the timeline of these calls and how does latency really impact this entire chain. So span traces is very similar to how an agent will go back to the LLM multiple times and invokes it. When you visualize that on a timeline, it becomes very clear that certain prompts are taking longer, certain tools are taking longer, and that will give you a sense of where is the bottleneck and what is causing the actual problem or the delay in making the agent come back with the correct response.
Okay. Relevancy of retrieval models then.
Yeah, so this is more like, there is a new technique that is coming up, which is called the re-ranker, where after you retrieve data from vector database, it may not be in the correct order. The chunks of data that is coming out of the vector database could be very ad hoc. They may not be sorted or structured in the most relevant order. So what happens is this is sent to another model called the re-ranker model. And the job of the re-ranker model is take 10 data points that came out of the vector database and sort them in an order where the most relevant data is at the top of the heap. Now, that re-ranker model is going to send the output back to your agent or the RAG application, and then it takes the top N or top K and then send it to the LLM. So when this happens, there is latency involved, and there is also there is a relevancy factor on how well your RAG system is performing. Because if your RAG system is not getting you the right data in the first attempt, that means there is something wrong with the chunking strategy or the embedding model strategy or the re-ranking strategy, and you got to go and tweak that. So measuring the retrieval and the re-ranking technique will give you a sense of how your RAG system is performing, and it's a very important metric to monitor.
Latency is one of my favorite topics.
Latency is a no-brainer. There are bottlenecks everywhere. You may actually end up hitting an endpoint that is getting throttled, or the agent is calling an external tool that is delaying the response, or the LLM itself is oversubscribed and it is struggling to come back with the number of tokens per second. So monitoring each of these and understanding where the bottleneck is, again, that's a very important metric. And latency is a very broad term, but when you break it down into each of the moving parts, it gives you an insight into where exactly the bottleneck is. And the next one in the order is usage monitoring. Obviously, usage monitoring is, you don't want your OpenAI bill to be like $1 million. So you need to basically make sure that every department has a quota, and you are measuring how the usage is, how many number of tokens are being generated by individual users at the team level, at the organization level, and basically break it down. So usage monitoring at the token level is very important.
Oh, I have all kinds of storage questions there, but we'll move on. User feedback.
Yeah, user feedback, again, going back to the ChatGPT or your favorite copilot, for every response, there is a thumbs up and thumbs down, right? So capturing that and correlating that with the prompt and response will tell you how often the model is performing accurately and how often it is drifting away, from what is expected. Basically, it's another metric to measure hallucination. It may not be hallucinating, it might still give you factually correct, but the user is not happy. So the user feedback will give you an insight into what was the prompt, what was the response, and how often the model is not satisfying the end user. So that's a very important metric.
That's a great summary. And I think it raises a lot of questions about how do people who work inside enterprise organizations manage all of these things. And this really gets into the discussion about the ecosystem itself. And there's a number of players in the ecosystem. We have Datadog, New Relic, Synios, Dynatrace. There's the tool LangSmith, which we know is part of LangChain. Phoenix is a part of what company?
Arise.ai.
Arise, okay. And then we have Truera. Maybe you want to take it from the top, or you can just kind of explain kind of what's going on here.
Yeah. So the entire LLM observability space can be broken down into two parts or two different categories. One is the usual suspects who deliver a catch-all observability solution. They are there for infrastructure, for ML, for data observability. So basically, all things observability they claim they are capable of, and they have some stake in it. So that's the reason why you see names like Datadog and New Relic, Dynatrace, who are proven players in the typical infrastructure observability. But now they are actually stepping up and offering LLM observability. Some of the things like token usage monitoring and API latency and infrastructure, GenAI infrastructure stack observability, and all of that. That is the first category. Basically, the extension of existing observability companies to offer LLM based observability. The next one is the completely the newborn, the new set of new breed of companies which are built exclusively for LLM observability, and they don't have.
So just to back up a little bit, so we would say it's kind of the companies who've been around a while. Datadog, New Relic, and Dynatrace are the three that you have listed here, and they have provided those traditional, metrics that you discussed earlier, MELT, right? And
Yeah.
So now we have a whole new set of vendors, and those include Syneos, LangChain, and others. So I just want to provide that context.
Absolutely. Thanks for clarifying that. I think it makes it very clear. So we have these companies that are built from the ground up, keeping GenAI stack in mind, LLMs in mind. And then we have the usual suspects who are also clicking that checkbox of LLM observability. Now, most of the companies that are new in terms of LLM observability, they are offering the metrics and the evaluations related to some of the metrics, some of the data points that we talked about, like how do you perform model evaluation, how do you measure hallucinations, how do you perform span traces, how do you measure the relevancy of retrieval models and re-anchor models, token usage, latency. So all these basically have libraries, and they remind us of APM, the very early days of APM, like the app dynamics of the world, where if you are a Java developer, you had to import a library and then instrument your code so that the logs are sent to an APM endpoint, and you can visualize a lot of details about your application. So LLM observability is a lot like APM. If you are a developer implementing RAG, or if you are a developer writing LLM application, you got to import a library and wrap your calls inside that. And as and when you actually make an outbound call, it gets recorded. It goes to the SaaS control plane if it is running outside, or if it is an open source project, it is all within your environment, and you can basically measure all these key metrics. So I would say the new breed of LLM observability companies, particularly like Truera, Phoenix, and even Langsmith, are a lot like APM for LLMs.
APM for LLMs. And APM is a term that's been around for decades. And so what is the corollary to APMs of old?
So I call that as APMs for LLMs. It's the same mechanism. How do you perform distributed tracing? How do you basically implement circuit breaking? Or how do you really pinpoint to where the API chain is broken, or where the bottleneck is? So APMs precisely deliver those insights. And today, if you look at what these companies are doing, like Langsmith and all of them, they give you exactly similar insights into your LLM stack.
Johnny, here's what I would like to do. And you can tell me if you're up for this or not. I think this is a great place to take a pause. And We should follow up another time and go through each one of these companies as one episode. Are you up for that?
Yeah, absolutely.
Okay, great. Because I think we can really get into the differences in these companies, which would be a lot of fun to do. So I want to thank you so much. We finally got it right. Johnny and I took a few takes to get this one going. I actually finally
No
pressed the
problem.
record button, so that helped too. But but thanks, Johnny, so much. And I can't wait to see you in Paris.
Absolutely. Same here. See you soon.
All right. Bye-bye.
Thanks, Alex.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.